On this problem here, we're given a graph of a function f, and we're being asked between -2 and 4 where this function is non-differentiable, or in other words, doesn't have a slope. Now, this problem gives us some information in the problem itself by telling us that there is a vertical tangent at the point 2, 0. So if you guys look at the point 2, 0 on our function here, a vertical tangent is actually a tangent that does not have an actual slope, because we know a vertical slope is undefined, or a vertical line has an undefined slope. The other information they tell us is that we have horizontal tangents at the points 1, -1, and 3, 1. So if you look at this graph carefully, 1, -1 is a point on our graph, and so is 3, 1. And both of these points have horizontal tangents, which means that the slopes there are equal to 0. Now, there's one other place that we need to look at on this problem, even though it's not stated in the question, and that's here at x equals 0. If you notice, that is a jump discontinuity. So when a function, or when a problem is asked when a function is non-differentiable, there are 4 situations to keep track of. The first one is a corner. The second type is a cusp. The third type is a vertical tangent. And the last type are any of the discontinuities, whether they are jump, infinite, or removable. These are the types of points that are considered non-differentiable. So, where are the locations where f is non-differentiable? That would be at x equals 0 and at x equals 2. If you said at x equals 1 and x equals 3, notice that we do have differentiability at those 2 locations where the slope is equal to 0, so those would not be considered non-differentiable. Here's another function that has a lot of issues. If you'd like some practice finding points of non-differentiability, try to name all of the x values where we have non-differentiability, or in other words, no slope, and identify what type it is. Good luck, check the comments.